All right, so now that you wrote down all the properties and everything, and we have all the graphs now, now we're going to actually find out the values of different parts of these graphs, and we're going to use the properties to help us find those values. So we should be able to figure them out quickly and move forward, and not actually take your time and spend hours upon hours trying to figure out what's going on. So for example 1, we're going to find the value by referring to the graphs of the trig functions. Now, when we're doing that, that means we're going back. We should be able to go back to the properties and figure out the values and answers and work it out quickly. So if we look at tangent 9 pi over 2, 9 pi over 2. Now we know tangent, we said, okay, with that one, it should go through 0 and go through the pi's, all that great stuff. So pi over 2's, hopefully it should be like undefined. But let's go and take a look at this piece. From the properties of tangent, we said that if it's an odd integer for pi over 2's, sorry, if the asymptotes are at x equals pi over 2n, where n is an odd integer. So we know asymptotes, if we look at it, we can write this, well, not just asymptotes, but this part, if we look at it, we can rewrite this as tangent pi over 2 times 9. And here 9 is n, and n is an odd integer, right? 9 is an odd integer. So if that happens, that means that our value should be undefined. Now, if you don't remember this part, or if you don't remember those specific words there, remember the graph. Again, we know that when it comes to tangent, it goes through 0. When it comes to cotangent, it doesn't go through 0. There's an asymptote at 0. So here, if you remember that part, if the zeros are at 0, that means 0, pi, the 2 pi's, all the pi's would be at 0, would go through 0, and then the pi over 2's would be undefined. So it's up to you to remember that. Figure out a way to remember that. So that means here that tangent 9 pi over 2 is undefined. Oh yeah. All right. And then let's go to cotangent 7 pi over 2. And again, going back to what we talked about with our integers and all that great stuff and our parts of the graph, you should remember this part. So here, if we look at this part again, oh, sorry, there's more stuff right here. So we know that the x-intercepts are located at pi over 2n. Because again, when it comes to your values here, we know that at 0, pi over 2 pi, and all that stuff for tangent is at 0. But when it comes to the other parts, that's where across the x-axis, your x-intercepts, where x is equal to 0. So this is where x equals 0 at pi over 2. So when there's an odd integer, that's when it's the x-intercept. And that's from number 4 of the cotangent properties. So here, that means for this part, we can rewrite this again at cotangent pi over 2, and that's 7. And 7 is an odd integer. So if that happens, that means we're looking at x equals 0 for this one. Well, not x equals 0, but cotangent, let's write it here. Cotangent 7 pi over 2 should equal 0 because that's your x-intercept. Okay, so not bad. We can do that quick. All right, so now let's move on to example 2 before I actually give you practice. So example 2 here, it says now let's find the values of theta for the angle for which each equation is true. So we need to find out, no matter where we are on the graph of cosecant and secant, where these values are always going to happen. So not just at one spot, but every single spot. So it means you can't just tell me pi over 2 or 7 pi over 2 or pi over 4 or anything of that sort. You have to tell me where it's going to be every time. And again, we're going to pull back what we know from the properties of secant and cosecant to help us to answer that. Now, if you go back to the values when it comes to secant and cosecant, not values, properties of cosecant and secant. If you go back to the property of cosecant, if you look at the actual value for 1, where the function equals 1, in other words, when y equals 1, because this is considered our function, which is y, function, f of x, same thing as y, cosecant is y. So when y equals 1, it says this happens when x equals pi over 2 plus 2 pi n. And here, this is when n is an integer. So n is an integer. So if that happens, that n is an integer, and I think I spelled it right. Yep, I spelled it right. Yay. So at this part, the only thing that we need to really write down is just that. So this is going to tell us every single time that n is going that cosecant is going to be equal to 1. So it's going to be x is going to equal, or let's say theta. Let's not say x, let's say theta, because we're talking about the angle theta. So theta is going to equal 1. Well, theta, the cosecant of theta is going to equal 1 when we have pi over 2 plus 2 pi n. So that could be pi over 2. Add 2 pi to that. That would be, what, 4 pi. So 5 pi over 2. And then keep going on and adding another integer for each one of these n's. So that would be pi over 2. That would be 5 pi over 2. And then we keep adding 2 pi. So if we do 4 pi, because we put a 2 right here for n, that'd be 4 pi. Then that'd be 8 pi, so that'd be 9 pi over 2. But then that also takes care of the negative integers too, negative numbers here. So that takes care of every single number that will ever work for cosecant theta equaling 1. So this formula right here. Again, if that doesn't make sense, stop me, and then I can come over and stop the video and I can come over and help you out and everything, and hopefully explain another way or even more in depth. All right, then the other one is for cosecant, and when that's equal to 1. So equal to negative 1. So when y is equal to negative 1 here. So here, when it comes to the properties, again, this is number 8 on the properties. And it says when theta equals pi n, and where n is an odd integer. And again, this is all we need to write down, because that's going to tell us when this happens every single time, no matter where you are. So that means it could be pi. It could be an odd integer, 3 pi. Could be 5 pi. But also could be negative pi or negative 3 pi. So it's going to go on forever in both directions. But this part right here tells us where it is. Okay, cool. Now, at this point, now that we've gone through example 1 and 2, here is your practice that I want you to work on. And again, you're going to do this on a separate sheet of paper and turn it in to me. But you're going to do all the practices the same way we just did them when it came to examples 1 and 2. So go ahead and stop it, write them down, and then move forward. Alrighty.